it. So do you guys like remember what is this? This is actually a trigonometry table that we have like used in your 10th or 12th grade to calculate your angles using sine theta, cos theta, tan theta. So here we are like discussing about your cosine similarity. So we'll be like looking into only this table. Okay, so the value of cos 0 is 1, 90 degree it's 0, 180 is minus 1, and 270 is 0, and 360 is 1. And when you like see, it is like the whole values, including your 30 degrees, 45 degrees, everything relies between minus 1 and plus 1. So your cosine value similarity is also like ranges between minus 1 and plus 1. Okay, so it's a cosine similarity is nothing but your measure of similarity, where you're trying to measure it measure it through the angle between the two different vectors. So imagine in the space you have like two different vectors, and you're able to find out what is the angle, and if you like find the cosine like cosine of that angle, you'll be able to find the cosine similarity. It's very simple. Okay, so for example, here you have this diagram. You have two vectors based on the point 1 and 2. So we have two vectors from the origin. So the angle between these two vectors is like taken cosine of it, and you will get an answer. So that becomes your cosine similarity. Okay, so the another formula for this is like cos theta equal to a into b divided by mod of a into mod of b. Okay, so for example, here imagine if the angle is a 30 degree and cos 30 degree is 0.5, so which means the points are 50% similar. Okay, and if the angle is around 90 degree, your value becomes 0, and which means your points are completely different to each other. For example, when the value becomes 90 degree, imagine this is your angle, imagine these are the two vectors, your value becomes 90 degree. What happens? Your cosine uh, 90 is cos 90 is 0, so they are totally different to each other. And imagine you have 2 points here. So imagine you have a point here as well as here on the x-axis. Your angle becomes 0, right? Your angle becomes 0. So cos 0 is 1. So which means the similarity is 100%. There's a very good chance. I mean, those points are completely similar to each other because it lies in the same plane, right? Okay, so let's like apply some numbers to compute the cosine using the formula. This the same formula here. Here we are using the variables a and b. Here it is like d1 and d2. So imagine you have two points d1 and d2. So cosine that is the formula to like compute the cosine similarity is d1 into d2 divided by d1 mod of d1 into mod of d2. So imagine we have like 2 points here. So it is actually a multi-dimensional plane. So we have the points 3, 2, 0, 5, 0, 0, 0, 2, 0, 0. So this is your T1, this is your T2. Okay. It's actually a multi-dimensional space. So your point D1 point looks like this, and D2 point looks like this. So you're multiplying D1 into D2. So 3 into 1 plus 2 into 0, 0 into 0, 5 into 0 plus 0 into 0, 0 into 0 plus 0 into 0 plus 2 into 1 plus 0 into 0 plus 0 into 2. So when you compute this, you'll get 5, and you're computing mod of D1. So it means you're like squaring the same way, value, 3 square plus 2 square plus 0 square, it goes on, and you're taking a square root. So it's square root of 42, which gives 6.481, and the value of mod d2 is you get square root of 6, which is 2.205. So when you like apply this values here, d1 into d2, it's 5 divided by 6.4 into 2.2. So you get the value 0.3150. So there are like two methods of calculating cosine similarity. Either you can like measure it through the uh, cosine of the angle, or you can like use the formula a into b divided by mod of a into mod of b. Okay. Okay, this is a small representation of how you can like measure this distance. For example, imagine you have a points a and b. Okay. So you if you like try to like create a triangle from the origin. So from the origin, I'm drawing a vector to a, another vector to b, with magnitude and direction. So when you like join these 2 points, okay, so this line helps us to like determine your Euclidean distance. And when you like uh, measure the distance between this using these two planes, these two vectors, this becomes your Manhattan distance. And when you like measure the angle and take a cosine of it, that becomes your cosine similarity. So these are the different measures of calculating similarity. Okay, calculating these are distance measures, your Manhattan, Euclidean, Minkowski, this cosine similarity, everything tells you about the points that you have in your data. Okay, and the formula for cosine distance is 1 minus cosine similarity.